Hello again. So I've got a lot of things I kind of want to go through today. We've got a little bit of notes. We've got a warm-up on velocity and acceleration. We've got a quiz coming up tomorrow, so I want to do a little bit of quiz review too. So you should have this sheet in front of you. This is velocity and acceleration warm-up number 2. You hopefully also have a sheet that looks like this, some notes that I've partially written out for you like yesterday, and you should have a review for derivatives and velocity quiz that looks like that. So hopefully you've got those 3. I want to start with this, so put that on top. All right, so your quiz tomorrow is going to have some questions, or at least one question on velocity and acceleration. So I want to go through this warm-up together. So the particle moves along a path horizontally according to the function s of t equals 6t squared minus t cubed minus 9t. So that's a position. Find v of t. How is the velocity related to the position? It's the derivative. So v of t is equal to the derivative of position. So that means v of t is 12t minus 3t squared minus 9. Done. Next, find a of t, acceleration. How is acceleration related to position? Well, acceleration is the second derivative. Or you can think of it as the derivative of the velocity. Either way, take the derivative of that velocity function we just got. You should end up with 12 minus 6t. Okay. Part C. At what time or times is the particle at rest? What does at rest mean? That means velocity is equal to 0. So take your velocity function, 12t minus 3t squared minus 9, set it equal to 0. We're definitely going to want to reorganize that. So let's make this negative 3t squared plus 12t minus 9 equals 0. Now I left the negative on this side because when we partition later on, that negative is going to come into play. The function actually is negative. So moving it over to the other side is cheating a little bit because obviously negative 3t squared is not the same function as positive 3t squared. So we've moved it over in the past because when we're solving an equation it wouldn't matter. But if I care about when is the function positive or negative, that is going to matter. So leave it over here, but factor it out. We're going to take a GCF of negative 3 out. That leaves me with t squared minus 4t plus 3. Factor. So now I've got t minus 3, t minus 1. So you can see I'm going to get that t is 3 and t is 1. So 3 seconds and 1 second is when the particle's at rest. Okay, part D. When is the particle moving to the right? Now the velocity also tells us the direction that it's moving in addition to the speed. So remember, this is when I partition velocity. I'm looking for when is the velocity positive. So here's my partition for velocity. I don't care about anything less than 0. I got to put where the velocity is 0 though, so that 1 and 3 that I just found definitely go on the number line. And if I plug, let's say I plug 1/2. If I plug 1/2 into this formula right here, we'd have a negative 3. 1/2 minus 3 is negative. 1/2 minus 1 is negative. 3 negatives make a negative. If I plug 2 in, negative 3 is still negative. 2 minus 3, that's negative. 2 minus 1 is positive. That makes that positive. Plug 4 in. Negative 3 is negative. 4 minus 3 is positive. 4 minus 1 is positive. Negative overall, though. So when is it moving to the right? When it's positive. So from 1 to 3 seconds. Or you can write it as interval notation from 1 to 3. E, what is the particle's position when its acceleration is 0? So position means I'm going to want s of t eventually, but I want to know its position when its acceleration is 0. So first I got to solve when is the acceleration equal to 0. Well, acceleration we found back up here. It's 12 minus 6t. So where is 12 minus 6t equal to 0? Well, if I subtract the 12, I get negative 6t equals negative 12. So t is 2. So really I want the position when t is 2. So I'm looking for s of 2. I look back up at what position was. 6t squared minus t cubed minus 9t. So s of 2 would be 6 times 2 squared minus 2 cubed minus 9 times 2. And you should be trying your best not to use your calculator, because tomorrow's quiz is non-calculator. So this is 6 times 4 minus 2 cubed is 8 minus 18. So 24 minus 8 minus 18. 24 minus 8 is 16. And 16 minus 18 is negative 2. So its position is negative 2. And then finally, a total distance traveled problem. What is the total distance the particle travels in the first 4 seconds? So remember what we need. We need endpoints. So 0 seconds to 4 seconds. Those are my endpoints. And I also need to know when the particle's at rest. Because when it's at rest, that's when the velocity changes from going left to right. So I need to look at s of 0, s of 1, s of 3, and s of 4. So I always look at my endpoints of the interval I care about, and any time in there when the particle is at rest. So again, I'm using the formula s of t. I'm just going to rewrite it down here so I can see it. Equals 6t minus t cubed minus 9t. So s of 0, plug 0 in everywhere, you're obviously going to get 0. Plug 1 in, 6 times 1 minus 1 cubed minus 9 times 1. So that's 6 minus 1, that's 5. 5 minus 9 is negative 4. S of 3 would be 6 times 3 minus 3 cubed minus 9 times 3. So that's 18 minus 3 cubed is 27. So 18 minus 27 is negative 9. Negative 9 minus 27 again. Sorry, what am I doing? 6t, oh, sorry, 6t squared, I wrote it wrong. Try that again. This is really 9 times 6, so 54, minus 27, minus another 27. That comes out to be 0. And then plug in 4. 6 times 4 squared, minus 4 cubed, minus 9 times 4. So 4 squared is 16. You might have to do it on your calculator, 16 by 6, but you don't have a calculator, so old school. That's 36, 9, so that's 96, minus 64, minus 36. That's going to come out to be negative 4 again. So to find total distance, what did I really do? Well, let's map it out. I started at 0. I went left to negative 4. Then I went right to 0 again. And then I went left to negative 4 again. So from 0 to negative 4, that's a distance of 4. From negative 4 to 0, that's a distance of 4. And from 0 back to negative 4, that's another distance of 4. 4 plus 4 plus 4, total distance traveled is 12 units. Okay. So there's a review of velocity and acceleration, and that will come up on the quiz tomorrow. All right, let's switch over to the somewhat filled in note sheet. So let's look at this. Day 34. Now, equation of normal line is on the quiz tomorrow. So make sure you're paying attention to this part. I'll show you what the question will look like in a minute. But this is a pretty easy topic. Normal line. Normal line is just a line that's perpendicular to a tangent line at the point of tangency. So if I want the normal line at x equals a, here's my tangent. The normal line is the line that's perpendicular right there. So I'm looking for the equation of that normal line. We know we can find the slope of the tangent line by finding what does slope mean in calculus? Derivative. And then how is a perpendicular line related to the line it's perpendicular to? Well, the slope is the negative reciprocal. So once I find the slope for the tangent line, I take the negative reciprocal of it. That'll be the slope of the normal line. So the only new step is taking that negative reciprocal. So, first example, write the equation of the normal line to this equation at x equals 3. Remember how I like to write goals. Here's my goal. My goal is the equation of a line. I need a point. I know the x coordinate's 3. How do I get the y coordinate? I plug 3 into the function. So if I do f of 3, so if I plug 3 in here, it comes out to be 85. I wouldn't expect you to do that without a calculator. The slope is going to be the negative reciprocal of f prime of 3. So normally I can just find f prime of 3, that's my slope. Now since it's normal line, I need the negative reciprocal of whatever that is. So I got to find f prime. So f prime of x would be 3x squared plus 10x plus 2. So specifically at x equals 3, f prime of 3 would be 3 times 3 squared plus 10 times 3 plus 2. Let's get some practice. 3 times 9 is 27 plus 30 plus 2. 57 plus 2, that's 59. So this is the slope of tangent line. So the slope of the normal line would be what? Negative 1 over 59. It's negative reciprocal. Okay, so then write your equation. We've got y minus y1, which is 85, equals the slope, negative 1 over 59, times x minus 3. Done. Okay, let's do one more. Write the equation of the normal line in general form to f of x equals 2x minus 1 over 2x plus 1 at x equals 1. Now I threw this in here as one of my side hints that I like to throw in before quizzes sometimes. We haven't seen general form in a while. We did that literally the first day of school. ax plus by plus c equals 0. General form of a line just means you bring everything to one side and make it equal to 0. So we're still going to start with point slope form. So I'm looking for y minus y1 equals m times x minus x1. I'm just going to get it in general form after that at the end. So we know we need a point and we need a slope. Our point is x equals 1. So when x is 1, what's the y value? The top would be 2 minus 1, so that's 1. The bottom would be 2 plus 1, so that's 3. So it looks like 1/3 is our point. Slope, since it's the normal line again, it's the negative reciprocal of f prime of 1. So I got to find f prime. So how am I going to find f prime here? Quotient rule. So I take the bottom, 2x plus 1, times the derivative of the top, which is just 2, minus the top, 2x minus 1, times the derivative of the bottom, which is just 2, all over bottom squared. Okay, what next? Distribute, combine like terms. So we've got 4x plus 2, distribute that negative also, so minus 4x. It would be a minus 2, but now it's a plus 2. All over 2x plus 1 squared. 4x's cancel, so I have 4 over 2x plus 1 squared. So what's f prime of 1 then? Well, f prime of 1 would be 4 over 2 times 1, which is 2, plus 1 squared. That's looking like 4/9 to me. Okay, so now, one second. Sorry about that. So if my slope is 4/9, the negative reciprocal slope for my normal line is going to be negative 9/4. Okay, so now I write my equation. Y minus 1/3 equals m, negative 9/4, times x minus 1. Now if I want it in this form, ax plus by plus c equals 0, I've got to distribute this through. So normally I'd stop at this step, but it wanted this general form. So let's get it in that form. Y minus 1/3 equals negative 9/4 x plus 9/4. Now the other thing is I don't love seeing all these fractions here. I want a, b, and c to be whole numbers. So what's the easiest trick to get these all to be whole numbers? Again, I'm doing this for help on the quiz tomorrow. What's your LCD? Well, I've got a 3 and a 4, so my LCD is 12. If I multiply everything by 12, it's going to get rid of all these fractions. Kind of a math trick. So I've got 12y minus 12 times 1/3 is 4, because they cancel, left with a 4, equals, on this side, negative 9/4 x times 12. This is going to cancel, being left with a 3, so that's negative 27x. Same over here, but it'll be plus 27. So if I make it all equal to 0, I would have 27x plus 12y minus 31 equals 0. Equivalent form of a line, just a form that we haven't been using quite so often lately. Okay, so that's normal line. Basically just remember negative reciprocal of the slope that you find. That will be on the quiz tomorrow. If you turn it over to the back, chain rule will not be on the quiz tomorrow. But we started it yesterday. I wanted to see if you still remember it, keep it fresh in your mind for after the quiz. So remember chain rule. The derivative of the outside times the derivative of the inside. So if I said find y prime for 3x squared plus 5x minus 2 to the 6th power. Yesterday I said just think of this as stuff to the 6th power. So stuff to the 6th power is 6 times the stuff to the 5th power. So leave that stuff alone to begin with. So this 3x squared plus 5x minus 2 just stays in there. But then I got to multiply by the derivative of that stuff, which is 6x plus 5 in parentheses. And there's not really anything more I can do here. I could distribute the 6 if I wanted to, but I'd probably just leave this as 6 times 6x plus 5 times 3x squared plus 5x minus 2 to the 5th power. Now here's something I want you not to do. This is the common mistake. People will say derivative is y prime equals 6 times 6x plus 5 to the 5th. Done. What did that person do? They took the derivative of the stuff too soon. You've got to take the derivative of the outside all on its own, ignoring that stuff, leaving that as is, and then multiplying by the derivative of the stuff afterwards. That's the chain part of it. So don't fall into that trap. Bad. Okay. Second one. Sine of 5x. That's like sine of stuff. So the derivative of sine of stuff is usually cosine of stuff. So this would be y prime equals cosine of stuff. Then multiply by the derivative of stuff. What's the derivative of 5x? It's just 5. So y prime equals 5 cosine of 5x. Done. Now when you get to these last couple, they get a little more involved. Cosine cubed of 2x plus 1. Now cosine cubed, remember what that really means. That really means I have cosine of 2x plus 1 multiplied together 3 times. So I like to think of it like this, with the cubed on the outside. We don't usually write it like that, but it'll be easier for us to think of with chain rule. Because this is actually double chain rule. I've got to take the derivative of this cosine raised to the 3rd, Then I've got to take the derivative of the cosine part of it, but then cosine has more stuff inside. So it's a triple chain, or a double chain rule. So first, deal with the outermost function. So 3 cosine of 2x plus 1 to the second power times the derivative of the inside, but that's another chain rule. Cosine of stuff. Derivative of cosine of stuff is negative sine of stuff times the derivative of that stuff. 2. Clean it up, put it all together. I can multiply 3 and 2. That's going to be, and there's a negative, so I'm going to say negative 6. I'm going to write this as cosine squared of 2x plus 1, sine of 2x plus 1. We're okay with that? I just combined the numbers and the negative. I rewrote this using the notation I prefer with the cosine squared up there now that I'm done taking the derivative. And then I've got this sign on its own at the end. Okay, last one. Tangent of cosine to the fourth of 3x. This is even crazier. There's 4 chain rules going on. I got to take the derivative tangent of stuff. Then the inside here is cosine to the fourth. That 4 is going to have to come out like this last one. And then deal with cosine. And then deal with 3x. There's a lot going on here. So, take it piece by piece. The outermost function is tangent. The derivative of tangent is always secant squared. So that turns to secant squared of that stuff. But now I got to take the derivative of that stuff, which is really cosine 3x to the fourth. So that's power rule. 4 comes out front. Now it's cosine to the third power of this stuff. Okay. Now I've got to take the derivative of the cosine piece of that. Cosine of stuff. Derivative of cosine is negative sine of stuff. And then finally, the stuff inside there is just times 3. Pretty intense, but that's where chain rule comes from. It just keeps on going. Okay, so let's clean that all up. What can I put out front? I've got a 4, a negative, and a 3. So negative 12 secant squared of cosine to the fourth of 3x times cosine to the third of 3x times sine of 3x. And that is an intense chain rule. Okay, so there'll definitely be more chain rule in the coming days, but for now, put that in the back of your mind because that's not on the quiz tomorrow. However, you will be happy to know that you can do problem set 33 now. And make sure you assign that to yourself on the assignment sheet. That will also be due Friday. So make sure that's added to your list. Okay. Ready for some quiz review? How much time have we got? Okay, we're doing pretty good. Let's look at this review for derivatives and velocity quiz. This is a review sheet that's up to you if you want to do. The answers are attached. You know how it goes. Quiz is tomorrow. Some things about the quiz. First off, there's no calculator. Sorry. There's multiple choice and short answers. So some no partial credit, some partial credit. Things to know. Derivative rules. Product rule and quotient rule are both going to be on there again. Again, no chain rule, but think about tricks. Tricks are things like b down here. Find the derivative and simplify. F of x equals 1 over 2x to the third. What would I say to rewrite that as before you take the derivative? It's 1/2 x to the negative third. Then take the derivative. You haven't actually taken the derivative yet. So this would be f prime of x equals negative 3/2 x to the negative fourth. Sorry, yeah. So that would be negative 3 over 2x to the fourth. So rewrite it using a trick, then take the derivative. Just don't forget to take the derivative. Other tricks, this would be quotient rule. This is quotient rule. This is product rule, but remember, we're going to write this as x to the -1. We're going to write this as x to the 1/2. But I would use product rule on that one. Slope equation of tangent lines and normal lines. So that new piece is on there. Remember, negative reciprocal of the tangent slope. Trig derivatives. Remember all those trig derivatives. If you look at yesterday's notes, I wrote them all out for you again. Know the trig derivatives. Velocity acceleration. We did that at the beginning of class today, so you've reviewed that already. There's another one on here to practice. And application word problems. I want to show you what I mean by that. I'll go over one of those at the end here. Okay, so let's just look through this review sheet. I kind of talked through these already. Make sure you know product and quotient rule. This one's kind of fun. Given the graph of g prime, the derivative of g, determine all values of x where g is increasing. That's the key. Make sure you know what you're looking at. This is g prime. That's not g. That's the derivative. And if you see the derivative, what does that mean? Derivative means slope of g. So when it says determine all values of x where g is increasing, I want to know where is g, what's happening. Okay, so when g is increasing, what's true about the slope? Slope is positive. So where is the slope positive? Well, this graph is the slope. Where is it positive? It's positive here. It's positive here. It's when it's above the x-axis. So any place where the slope is above the x-axis is where the graph would be increasing. So this is increasing from, that's 0, so -1, -2, -3 to -1, and 2 to infinity. Okay, so be careful of ones like that. Over on the back, there's some more fun. Here's a slope with a normal line question. If ax squared plus 2x minus 7 is f of x, and the slope of the normal line is 2 when x equals 4, find the value of a. Well, that's tricky. If I'm talking about slope, what do I probably need to find? The derivative. So f prime of x equals, what's the derivative of this? A is just a constant. So it would be 2ax to the first, 2 times a, whatever a is, plus 2. So we know that the derivative of the normal line is 2 when x equals 4. So that means that f prime of 4 should equal what? Not 2, because that's the normal line, the negative reciprocal of 2. So I can use that to find a now. If I know f prime of 4, which is 2a times 4 plus 2, should be -1/2, then I have 8a plus 2 equals -1/2. Subtract the 2 over. We get 8a equals -5/2. And think of either dividing by 8, multiplying by 1/8, however you want to think about it. This is going to be -5 over 16. So there's your value of a. Little tricky, but hopefully makes sense. Here I want to find the equation of the tangent line at the indicated point. That's 2, 4. Looking for that equation. We know we're starting with y equals x squared. So this is one of those ones where I've got my goal, y minus y1 equals m times x minus x1. Already got my point. It's 2, 4. I need my slope. If you don't know how to find that now, probably won't tomorrow either. Number 5 is another velocity. Now this one I do want to mention. The object is moving according to this function. Find the average velocity. That's different from instantaneous velocity. Average velocity is just the same as regular old slope. It's a slope between 2 points. So I don't really need a derivative for that even. Average velocity would just be find the slope between 1 and 1.5. So this is slope of s of t between t equals 1 and t equals 1.5. Okay, so I would just do s of 1.5 minus s of 1 all over 1.5 minus 1. So plug in 1.5 and 1, find your slope. When it says instantaneous velocity, that's what you're more used to. That's when you find the velocity formula, which is the derivative of the position, and plug in 2. Part C says at what time will the object hit the ground? So if it's moving according to this function, when it's on the ground, that means when s of t equals 0. So it's moving up and down. When it's on the ground, ground is always 0. So I would just set the original function equal to 0 and solve it. And then D. D is a little different. When does the object reach its maximum height? What is the maximum height? Use calculus to find your solution. This describes the height of this object. What type of an equation would that look like? It's a parabola that's negative. So it's going to look something like this. So here's our maximum. Now you're not going to have a calculator tomorrow, so you can't just do good old second calc max. If I want to use calculus, what do we know is happening at this maximum height? What am I drawing in now? It's where the slope is 0, right? So find where s prime of t equals 0. Okay, well, what is s prime? Well, it would be negative 32t plus 100. Where does that equal 0? I can solve that, add the 32 over, divide by 32, and you're going to end up with 3.125 seconds equals t. So that's when it reaches its maximum height. What is its maximum height? Well, if I know when it reaches its maximum height, how would I tell what the maximum height actually is? Well, if you just take that and plug it into s of t, so s of 3.125 equals negative 16 times 3.125 squared plus 100 times 3.125. Obviously, you wouldn't know how to do that without a calculator. It comes out to be 156.25. But if a question like this shows up on the test tomorrow, since remember the test tomorrow is no calculator, you'd have nicer numbers to use here. Okay, so I went over some of those co-op problems on the review sheet. Do the other one if you want to study for it tomorrow. Look over these ones. The ones I hate are the ones that I think are the trickiest, so that's why I wanted to talk through them. If you have any questions, shoot me an email. I'll be in school early tomorrow. If you want to meet before the quiz, I'll be here by 6:30. That's it. So good luck.